Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will discuss few properties of circles and how you can use those properties to solve questions related to coordinate geometry. So first of all, you have to identify that if you have a circle and you choose some point outside the circle anywhere, and if you want to draw tangent to the circle, you will be able to draw two possible tangents. So you can draw a tangent on one side and then you can draw the tangent on the other side. The property is that if you would draw two tangents from any external point, both tangents must be equal in length. So from the point that you draw a tangent to the point of tangency, the length of one tangent must be equal to the length of the other tangent. Now, you can extend this idea by drawing a radius at the point of tangency and knowing the fact that tangent and radius should always be perpendicular to each other. So you know that this angle must be 90 degrees, and obviously the radii of the same circle must be equal as well. So this length is equal to this length is equal to this length, and obviously a common line between these two triangles obviously must be equal for both the triangles. Plus they also have equal right angle. That makes both the triangles as congruent pair of triangles. So that means this triangle would be congruent to this one, which would mean that this angle must be equal to this angle as well, and this angle must be equal to this angle as well. So you can obviously, once you have drawn tangents from the external points and then you have drawn a radius, then you will be able to draw two triangles which are exactly identical to each other. That is, they are a pair of congruent triangles. Now, how you can use that as a property, just have a look at one of the examples over here. We have been given an external point and we have to find out the length of the tangent from that particular point. So I have this external point. By comparing this equation with the standard equation of the circle, I would be able to find out the center of this circle. So once I found out the coordinates of the center of the circle, I know that this is a tangent, there must be a radius, and there must be a hypotenuse of this as well. So if I have a point and I have the center, I can apply distance formula to get the length of BC from point P to the center of the circle. I can also use the equation of the circle to identify the radius of the circle, because I know that this thing is equal to a square plus b square minus r square. So if I know the radius of the circle, I know this hypotenuse, so I can also use Pythagoras theorem to find out the length of this particular tangent. So that is how I can find or determine the length of the tangent. Another property that I would want you to know is that if you have a chord joining any 2 points in the circle, has to be any 2 points which are not forming the diameter, right? It's about every pair of points which are not basically the end of the diameter. So if you have a chord and if you drop a perpendicular from center to the chord, it will bisect the chord. That is, it is going to be dividing the chord into two equal lengths, and vice versa. If you have bisected the chord from the center, then it should be perpendicular. And then again, it also forms a pair of triangles which are congruent to each other as well. And you can also sort of identify that this length is going to be the radius of the circle. This length again would be equal to the radius of the circle. Now, how you can use that to solve the problems of coordinate geometry. Let's say you've been given 3 points on the circumference of the circle and you have to find out the center of that circle. Now, although it has been guided over here how you have to go about it, you pick one pair of points and find out their perpendicular bisector. Now, AB is a chord, and a perpendicular bisector of that chord must be passing through the center of the circle. So if you would just draw a perpendicular bisector, you would know that it has on it somewhere, there must be a center of the circle. Now, if you consider another pair of points, let's say B and C over here, and you find out the perpendicular bisector of these 2 points as well, so you know that this must also be passing through the center. So if this line is passing through the center and this line is also passing through the center, so if I solve these 2 lines simultaneously, I will be able to get myself the point of intersection, which must be the center of circle. Since center must lie on this line and center must lie on this line, then it must only be at the point of intersection of these 2 lines. So I can find perpendicular bisector of one pair of points by using midpoint, gradient, finding the negative reciprocal of the gradient, and finding out the equation of that perpendicular bisector. I can do the same thing with the other pair of points, and after finding the gradient of the pair of points and finding out the negative reciprocal of that, I can find out the equation of another perpendicular bisector. So if I have 2 perpendicular bisectors, I can solve them simultaneously. This equation and this equation, if I'll solve them simultaneously by elimination or substitution, that will be your choice. But if you will get their point of intersection, that point must be the center of the circle. I also have to write down the equation of the circle. To find the equation of circle, I would need the center of the circle, but I also would need the radius of the circle. And that should not be a problem for me anymore, because I have center and I have 3 points on the circumference. So if I find distance from center to A or center to B or center to C, each one of them should represent the radius of the circle. Here I have just found the distance from A to P, that would be radius. And then recalling the formula for the equation of circle, which is x minus a whole square plus y minus b whole square equals r square, I will be able to get myself the equation of circle. Now this is the equation of circle, but I can also expand and simplify this form. I hope you found this video useful. If you did, please do like, subscribe, and share with your friends. Thank you.